We are going to see automata theory. In that automata theory, Turing machine is the topic today. Actually, what is Turing machine? A Turing machine is an accepting device which accepts the languages. What type of language? Recursively enumerable language. That means the type 0 grammar. It was invented in 1936 by Alan Turing. The Turing machine is okay. So the Turing machine. What's the definition of this Turing machine? A Turing machine is a mathematical model which consists of an infinite length tape divided into cells on which input is given. Actually, in Turing machine, we have so many important parts. The input tape is in one of the part, and the input tape is one of the part, and the read write head is the next one. The head which reads the input tape and write and the outputs in that input tape. So the work of the head is reading and writing in the input tape. A state register is another part. That state register can store the state of the Turing machine, and after reading the input symbol, it is replaced with the another symbol. Its internal state is changed and it moves from one cell to the another cell. The another cell may be from right or left. If the Turing machine reaches the final state and the input string is accepted, otherwise it is rejected. So to accept a string, the input strings should be accepted, means it could have to reach to the final state. Okay, so the next, this is the model of the Turing machine. Whatever the components in that input tape, it is an infinite tape, both side infinite, both left and right side. It's an infinite storage device, infinite tape, and this is the read write head. It could reads a symbol and write the symbol to the input tape, and it takes the symbol to the control unit. Here the control unit can process the symbol. Okay, so these are the main components of the Turing machine: input tape, read write head, and the control unit. The tape, no boundaries, infinite length. The read write head um, can read the symbol from the input tape. It have no boundaries, both side it is infinite. It have more storage, and the read write moves left or right. It takes the symbol from left or from right. Okay, uh, so this is the process of this read write head. It could reads the symbol from the input tape. The head, at each time step, it can reads a symbol and writes a symbol to the input tape and moves left or right. This is the process of the input tape in the Turing machine. It's actually process of the read write head in the Turing machine. And for example, we should take a symbol or strings A, B, A, C. Okay, it could filled in that input tape now. The read write head first reads the symbol A. Okay, after reading the symbol, it sent to the control unit. The control unit can process the symbol. After process, it the output is K. So now the read write head writes the K into the input tape now. Okay, so whatever the process here going on, reads A and writes K after the process, and moves left the read write head. First it reads A and now it moves to left after completing the process. Okay, so here now it moves left now. So here in the left side the symbol is B. So now it reads B and sent to the control unit, and after control unit process, it stores the output F and writes the F into the input tape. Okay, so whatever the process here going on, reads B and writes F, moves right. Okay, now it moves right. Okay, like that the input tape and read write head can process in the Turing machine. The input strings are A, B, A, C actually, and some of the blanks also in that input tape. These are called as blank symbols. Okay, so the read write head can process the blank too. The head starts at the leftmost position of the input string, means suppose it starts with the A, this leftmost symbol A. Okay, are treated as a left and right brackets for the input written on the tape. Suppose it moves again left, it could reads the blank symbol too. Okay. Yes, whatever the transition going on in that, the states and the transition here, actually Q1 is the initial state. It takes the symbol A from the input tape, so it reads the symbol. Okay, after it after the process, the output symbol is B. It writes the symbol to the input tape B, and then it moves left. It moves left. When it moves left, the state can changes to Q2. Okay. Yes. Next, suppose it takes right. It moves right. Again, it moves to the next state Q2. Okay. It moves left or right. If it moves left, this is the process. If it moves right, this is the process. Okay. And now the current symbol is A. It reads A. Okay, it's in the current state Q1. Okay, so Q1, it's in the current state Q1, and it takes the symbol A from the input tape. After process, it gives the output B, and now it moves right. The next state is Q2. So like that you have to write the transition. Okay, this is the states and the transitions in the Turing machine. So the similar way, A, B, A, C, it takes A and replaces B after the process, and now it moves left and it takes the symbol C. Okay, so it moves right. Okay, it moves right. So this is the process. Current state is Q1, takes the symbol A from the input tape and writes the symbol. After the process, it writes the output symbol B into the input tape. Okay, and moves right. It's in the next state Q2 now. Okay, so like that some process is going on. If suppose in the previous one it moves right, in the next one it moves left. Left means it again reads the B symbol. Okay, so this is the process. Suppose it reads, after reading the C, it moves and reads the blank symbol. Now the current state is Q1. It reads the blank symbol. Okay, and replaces the output symbol G. Okay, and writes the G into the input tape instead of that blank symbol. This is the output symbol. Okay, and moves right. Okay, the similar progress for any symbol it could takes from the input tape. So okay, when the Turing machine can allow the symbol and not allow the symbol, the Turing machines are deterministic one. Okay, actually the Turing machines are deterministic one. So this is the Q1 is the current state, and it takes the symbol A, and the output symbol B could be right in the input tape, and it moves right means this is the process. Okay, suppose it moves left means this is it reaches to the Q3 state. Okay, so this can be allowed by the Turing machine because it is deterministic one. So okay, here not allowed state we can consider. Here the current state is Q1. It takes the input symbol A and gives the output symbol B, and R is it moves right, it moves right. Okay, so now it's in the state q2. A is the current symbol, and suppose it moves left. Okay, and gives the output symbol D and moves left. Here the another symbol can be reached by. Okay, no lambda transition is allowed here, only the original process, because it is deterministic. No empty symbol can be allowed. Okay, so this is the process. Now the machine can halts. So when the machine could halts means no possible transition is followed by the machine halts. Okay, so the final state q1 to q2. q2 it reached to the final state at last means the string is allowed. It not reached to the final state at last means the string not allowed. The final state have no outgoing transition. This is the final one. Okay, actually here in final state the machine halts. That's it. Okay, so these are the process of the Turing machine. What when we say the machine can accept the string, the machine halts means in your halts at your final state means we say the string is accepted. It accepts the input string. Okay, when the machine halts in a final state at last, only in the final state the machine halts means the string is accepted, input string is accepted. When we say the rejection of input string, the machine halts in non-final state means the string was not accepted by the machine. The machine enters an infinite loop. So again and again and again it processes the same string. It could not reach to the final state at last. So the string not accepted by the machine, it rejected the input. Okay. So actually deterministic Turing machine means what? This is the input tape already we have studied, and the strings are there and some blank symbols also enters. It's an infinite storage input tape. Finite control, two-way infinite tape broken into cells, each containing one symbol. Two two-way read-write tape head is here. It could move left and right both side, left right infinitely left right move can be possible by the read write head, and a finite control containing the position of the read write, and it controls the current symbol being scanned and the current state too. Okay, so the it, it changes the what the process of Turing machine changes the state and prints the symbol over the cell being scanned and move its tape head one cell left or right. These are the process of the Turing machine. Okay, and now this is the formal definition of a Turing machine. Q sigma del gam, gamma delta q naught b f. Here these are the 7 tuples of the deterministic Turing machine. Q means the set of states, finite set of state, and sigma means the set of alphabet, input alphabets, whatever the inputs we can store in the input tape, that is the sigma, and a gamma. Gamma means the tape alphabet which is strict superset of the sigma. Okay, it including the blank symbol too. So delta means the distinguished blank symbol which is in the B means the blank symbol, and delta means the transition process, and q naught is the initial state, and f is the final state. Okay, so this is the process. Q and gamma makes the q means the set of states, and gamma means the superset of these states. So both can process, and finally the read write head moves left or right and to take the next symbol. Okay, so initiatively Delta means the transition from one state to another state. After taking the symbol, specifies the next state symbol to be written and the direction of the tape head movement by M after reading symbol S while the state is in Q. Okay, so acceptance language and decided language. A Turing machine accepts the language if it enters into a final state for any input string W. The language is recursively enumerable, generated by type 0 grammar, accepted by the Turing machine. Okay, the Turing machine decides a language if it accepts it and enters into a rejecting state for any input not in the language. The language is recursive if it is decided by a Turing machine. There may be some cases where a Turing machine does not stop. In that case, it forms a loop again and again and again. So, such a Turing machine accepts the language, but it does not decide it. Could not accept. Okay, final state not been. These are the formal definition of a deterministic Turing machine. We have a 7 tuples, set of state, and a set of input alphabets, and the superset. Delta means the transition function, Q naught means the initial state, B means the blanks, and F means the final state. Okay, the instantaneous description have triple, that is alpha 1 Q alpha 2. Q means the current state, it's in the set of state. Alpha 1 alpha 2 is gamma star and is the current tape content of up to the right most non-blank symbol or symbol left or tape head. So the tape head is currently scanning the first symbol alpha 2 and start the computing, and after computing it could receives the output symbol. So actually the Q naught is the initial state. The we taken 001 as our example string. Okay, after reading 0 it moves to the Q1 state. After reading another next second 0, it's in the same state Q1 itself. Okay, again after reading 1 it could move to the next state Q2, and again it is 1, so it's in the same state Q2 itself. Okay, so the similar way it can process, and finally it reads the blank symbol. Now the input tape is blank and reached to the final state Q4, so the string 0011 is accepted by the Turing machine, we say. Okay, so this is the process. Okay, and thank you for listening. We will meet in the next video. Thank you.